Hey there. Today we're going to talk about kind of the next step of our inequalities unit. We're going to extend into linear inequalities at this point, which we're actually going to graph solutions on the coordinate plane instead of just graphing the solutions on a number line where there's only one variable. So today we're going to start with looking at solutions of linear inequalities. And their essential question is, how do I determine if an ordered pair is a solution? So we're going to take a look at, just first, the difference between the two types of inequalities that we're working with here. We have simple inequalities and linear inequalities in this unit. A simple inequality, as you see at the top of your screen on the left-hand side, simple inequalities just have one variable and we graph the solutions on a number line, just like we did last week. Okay. Linear inequalities is what we're going to look at next. And linear inequalities implies that we're working with lines because of that word linear. Now, linear inequalities can have either one or two variables. So you'll see an example here that kind of looks like a simple inequality, but it can also represent a linear inequality, something that we would graph using the coordinate plane. Otherwise, we have the other linear inequalities where we have two variables, x and y. Sometimes they can be written in slope-intercept form, like we see at the bottom in that last example. Sometimes they can be written in standard form, like we see here in the middle example. Okay, so today we're going to start moving forward with linear inequalities for the rest of the unit. So to determine if an ordered pair is a solution of the linear inequality, which is our goal today, here's our three steps. So the first step we need to do is we want to take the values of each variable and substitute it into the linear inequality. Substitute the first coordinate in for x, the second coordinate in for y. So just remember, every ordered pair has an x and a y coordinate to substitute into the inequality. Step two, we're basically we want to figure out what does each side equal. So we simplify the inequality so that you can do a comparison of both sides. And in step three, we have to interpret what we see with the inequality. If the inequality is true, then the ordered pair is a solution. If the inequality is false, then the ordered pair is not a solution. So how do we determine if an ordered pair is a solution to the linear inequality? We substitute x and y into the inequality. We simplify so that we can compare both sides. And then we check to see if it's a true or false inequality. So a solution is an ordered pair that makes an inequality true. An example of an inequality that's true might be something like this. 3 is less than 7. That would be true. Or even 8 is greater than or equal to 8. That is also true because those two numbers are equal to each other. So if we had ordered pairs, an x and y, that gave us those inequalities at the end, the ordered pair that we started with would represent a solution. Let's look at some examples. Example number 1 says, determine if the ordered pairs are solutions to x plus y is greater than or equal to 3. So for example A, we want to take our inequality, x plus y is greater than or equal to 3, and we are going to replace the value of x and the value of y. In our ordered pair, the first coordinate is always the x coordinate. The second coordinate is always the y coordinate. So when I substitute those values in for x and y, I get -2 plus 5 is greater than or equal to 3. Now I just want to simplify what I have. -2 plus 5 is +3. And we check to see if our inequality is true or false. So it says that 3 is greater than or equal to 3. Let's see, is that true? Well, I know that 3 can't be greater than 3, but I do know that 3 equals 3. So this is, in fact, a true inequality. That's not my answer, but it is true. So we would say that -2, 5 is a solution because it was true. That's my answer. That's how I write it out. Negative 2 comma 5 is a solution. Let's look at our second example. We're working with the same inequality. X plus y is greater than or equal to 3. We're going to substitute in the values for x and y. So x was the first coordinate, which was 4. Y was the second coordinate, which was negative 2. And we want to simplify over here. So add together 4 plus negative 2, which is 2. And we check to see if this is true or false. This inequality reads that 2 is greater than or equal to 3. Well, let's see. Is 2 greater than 3? No. Is 2 equal to 3? No. So this is a false inequality, which means that the ordered pair 4 comma negative 2 is not a solution. All right, so if it makes the inequality true, the ordered pair is a solution. If it makes the inequality false, the ordered pair is not a solution. Now, for example 2, we have an ordered pair 4 comma negative 2, and we're going to determine if it is a solution to these two different inequalities. So, for example A, it says that x is less than 3. Remember that when your inequality symbol points to the left, that's a less than symbol. So x is less than 3. Now, in my ordered pair, I see two numbers, x and y, or that represent x and y. But in my inequality here, I only see one variable. It's just x is less than 3. So I'm only going to use the x coordinate for part A. The x coordinate was 4. So when I substitute that in for my variable, I just get 4 is less than 3. Now, that is false. 4 is not less than 3. It's actually bigger than 3. Because it's false, we would say that 4 comma negative 2 is not a solution to that inequality. For part B, the inequality we're testing is y is greater than or equal to negative 2. Notice the inequality symbol points to the right, so that's a greater than symbol. So I am going to take the y coordinate, because that's the only variable in my inequality, and I'm going to replace negative 2 where the y was. And it says negative 2 is greater than or equal to negative 2. Is that true or is that false? Well, let's see. Is negative 2 greater than negative 2? No. Is negative 2 equal to negative 2? Yes. So this is actually true because we have the equality there. So what does that mean? How do we answer it? Well, it means that the ordered pair 4 comma negative 2 is a solution to that inequality. So if you only have an inequality with just one variable, it just means we're going to only use one of the numbers from the ordered pair. Just make sure that you're choosing the correct number. All right, last example. This time we have an inequality with x and y. So it's a linear inequality, and it's written in slope-intercept form. Remember slope-intercept form, like y equals mx plus b. Even though my equal sign has been changed to an inequality symbol, it's still slope-intercept form. We're going to learn more about graphing this later this week. All right, so we're going to take our inequality and we're going to do the same steps. We're going to substitute in the values of x and y from the ordered pair into the inequality. So the y coordinate was 4. Remember, that's the second number in the ordered pair. The x coordinate was negative 3. And everything else stays the same. So we have to try to figure out what this equals on the right-hand side. So you could type that into like the Desmos calculator will do that all at once, or you could even use like a regular calculator if you're careful. Or we can just do this one step at a time in our head. Starting with 2/3 times negative 3. remember to do that, a fraction times an integer, we multiply the numerator times the integer and then divide by the denominator of that fraction. So 2 times negative 3 is negative 6, and negative 6 divided by 3 is negative 2. We don't want to forget about the plus 6, so I take negative 2 plus 6, and that will equal 4. Negative 2 plus 6 is 4. So I get the inequality statement that 4 is less than 4. Well, is 4 less than itself? No. You can't ever get a number that's less than itself. So we would say this is false. Not our answer. We're just using that because it's false to say that negative 3 comma 4 is not a solution. At least to this inequality, it's not. All right, so that's our lesson for today. Just take your values for x and y from the ordered pair, substitute it into the correct variables in the inequality, and check to see if it makes the inequality true or false.